In this second video on parametric equations, we're going to look at differentiating parametric equations. We're aiming to complete the method for differentiating parametric equations and then applying the derivative, the result, to finding equations of tangents and normals to curves. The basic method involves use of the chain rule. So if we have a y equals a function of t and an x equals a function of t as our parametric equations, we can then find dy dt and dx dt and apply the chain rule in order to find dy dx. Notice that the dx dt has to be flipped to make it dt dx, so with the chaining variable, remember that these derivatives work like fractions, so we can cancel the dt's in order to get the dy dx. So you see here, part of the method is to flip the dx dt. Let's work through an example. Okay, so we have x equals t squared, so that means that our first derivative, dx dt, is equal to 2t. We also have y equals 2t, so if we differentiate that with respect to t, we get dy dt equals 2. Now remember back, dy dx equals dy dt times dt dx. So we need to flip our dx dt term. So that gives us, well, dy dt is as it is, which is just 2, and we get 1 over 2t, the reciprocal of the dx dt. If we flip it, we get 1 over 2t. So that gives us 2 over 2t, which equals 1 over t. So in other words, dy dx equals 1 over t. The last part of the question, we are told that t equals 3, so that then implies that the gradient, we'll call that m, equals 1 over t, which is just 1 over 3. So we're asked here to find the equation of the tangent to the ellipse. If you look at these parametric equations here, remember from last lesson when we have a cos and a sine and these numbers are different, these coefficients are different, that we get an ellipse. So the first thing we do is we differentiate. So x equals 3 cos theta, dx d theta, remember cos goes to minus sine, 3 stays there, the angle always stays the same, so we get minus 3 sine theta. For our y term, sine goes to cos, so we just get 2 cos theta for dy d theta. Then use the chain rule, remembering to flip the dx d theta, and we end up getting that, which ends up becoming 2 cos theta over 3 sine theta, and don't forget it's negative, so it's minus sine there. Okay, so to find m, we now put the pi over 4 value in. So when theta equals pi over 4, m equals minus 2/3, doesn't it? Because cos of pi over 4, cos 45 is 1 over root 2, sine 45 degrees is 1 over root 2, So we get, there we are. To find the C now, we put an x and y value in where theta equals pi over 4. So where for x, because x equals 3 cos theta, we put x equal to 3 cos pi over 4, and we get 3 over root 2. And then we do the same for y, and we get 2 over root 2 for y. If we sub those into y equals mx plus c, our equation of the tangent, we'll find the c value. So c equals 4 over root 2. Okay, we've just plugged in our y, 2 over root 2, our x, 3 over root 2, our m value, which is minus 2 over 3, and we get a value for c of 4 over root 2. Put that back into y equals mx plus c, and there's the equation. So the equation of the tangent is that. Okay, we'll work through an example finding dy dx for the curve given by these parametric equations, and we'll show that the equation of the normal at that point where t is 2 is 2y equals 8x minus 15. So if x equals t, obviously dx dt equals 1, and if y equals 1 over t, then dy dt, remember we can rewrite that as t to the minus 1 when it's in the denominator, so it goes to t to the minus 2, and it's times minus 1, isn't it? So we get minus 1 over t squared. Again, chain rule, dy dt, flip the dx dt, and because it's just 1, so it'll just be 1 over 1, we just get as dy dx minus 1 over t squared. If we put t equals 2 in, we get minus a quarter. We know that we're dealing with a normal here, so it's the same as the previous example with the tangent, but instead of using m now, we have to use minus 1 over the m value we found, the negative reciprocal, because remember, the normal is perpendicular, so the gradient of the normal is the negative reciprocal of the gradient of the tangent. So if we've got minus 1 quarter, that gives us a gradient of the normal of 4. Again, find the x and the y values. Just put t equals 2 into your equation for x and your equation for y. Then using y equals mx plus c, we've got our y value, our x value and our m value, which enables us to get our c value. Put that back into y equals mx plus c with our general y and our general x, and we end up with an equation of the normal that looks like that. Multiply by 2 and we get the equation that we were aiming at. Okay, so to summarise, to find the equation of a tangent at a point, we find the gradient function using our differentiating parametric equations, find dx dt and dy dt, and then use the chain rule, remembering to flip the dx dt term. We substitute the t value to find m. Be careful, make sure that you do this. Then to find the c value, we use x and y at a given point, so again use that t value to find y and to find x. Stick the y, the x and the m in to find c, and then sub back in the m and the c into y equals mx plus c. If it's a normal, it's the same procedure. but for the gradient we use the negative reciprocal. Okay, here's a couple of questions for you to have a go at. As always, if you're successful answering these questions, then you'll be well equipped for the lesson. Any problems, then go back over the video or go through this topic on My Maths or drop me an email and I'll help you go through it, help you understand it. Okay, here's the answers. So we've got our m value here. We then find x, find y, find c, and then sub back the m and the c. And there's the equation. For the second question, with the normal, again, use that method dx dt, dy dt, and then the chain rule, remembering to flip the dx dt term. We get a sine over cos, so that goes to tan, doesn't it? Put theta equals pi over 3 in. That gives us m value of minus 2 root 3. But remember, because it's the normal, it's the negative reciprocal, so sign changes, becomes positive, and it's 1 over 2 root 3. So that's the gradient we use. And then it's the same procedure again, find x, find y, substitute into y equals mx plus c to find c. We've now got an m value, an x value, and a y value. We get 3 over 2 for c, and then we just sub the m and the c back in, and we get our equation. And if we multiply by 2 root 3, that will get rid of any denominators and tidy it up a bit.